Hello, let us study about electromagnetic radiation. Now this tutorial will explain the electromagnetic radiation and its meaning, and the next thing is the properties of electromagnetic waves. So before we go on to understand the meaning of electromagnetic radiation, we got to understand certain basic points. That is, the energy is the capacity to do work. You may sit and work for 6 hours a day. You may you may study for 6 hours. So that is the capacity to do work. And energy exists in various forms. Third point, energy can neither be created nor be destroyed, but can only be transferred. The next point is energy is transmitted by the wave motion. It is transmitted in the form of a wave. The next point is, now what is radiation then? Now radiation is a mode of emission of energy, or you can say it is energy that is in motion. Now we got to understand certain things about wave as well. Now wave is nothing but a disturbance that is set up in a medium. For example, you would have seen the waves in the sea, or you would have also seen ripples in the water. Now when these ripples or waves are formed, they flow in all the directions. Now the next point, what is wave velocity? Wave velocity is nothing but the product of wavelength and frequency. Next point, sound waves require a material medium for propagation, and any waves that require a material medium for propagation, they are called as mechanical waves. Next point, light waves don't require any medium for their propagation, that is, they can even travel in vacuum. Next, the waves, that is vibrations, that are parallel to the line of propagation, the most important point. If the waves are parallel to the line of propagation, then they are called as longitudinal waves. Example are sound waves and spring waves. The next point, the waves, that is, if the vibrations are perpendicular to the line of propagation, then they are called as transverse waves. Examples are water waves and electromagnetic waves. Now these are the basic facts which will help us in understanding the production and uses of electromagnetic waves. Now there are certain other basic information which we require to understand the concept of electromagnetic waves. The first thing is that a current produces a magnetic field. How? For example, take a copper wire and wind this copper wire around a pencil. Now connect the two ends of this copper wire to a pencil torch cell, and now you can test the presence of magnetic field with the help of pins. Now this shows that a current produces magnetic field. Second thing is, now we have already seen from Faraday's experiment that whenever a magnetic field changes, then it produces a current. Now just like as waves create disturbance in the water, for example, we have seen these ripples in the water. Now instead of using a pen torch cell in the above example, if we use alternating current. Now how is alternating current generated? Alternating current can be generated using a spark discharge or using a dipole antenna. This alternating current produces a changing magnetic field, and because of the very nature of alternating current to produce current in every rotation but in the reverse direction, it means that the electric field generated in every half of a cycle, a disturbance is produced in the electrical field. Now this disturbance will result in the change in the magnetic field. Now these mutually perpendicular electric and magnetic fields, they propagate in all the directions, and they are called as electromagnetic waves. Now come to the figure below, and we can see that now there is a discharge spark over here. This produces an alternating current by the very movement of this. This alternating current produces an electric field. You can see an electric field over here. It is electric current. This electric current produces a magnetic field, which you can see it over here. And the nature of alternating current is current flows in the reverse direction at every half of a cycle. The electric field and the magnetic fields, they are produced in a direction that is perpendicular to each other, and they propagate in this direction z. Now let us understand the distance between two corresponding points on the wave. They are called as wavelength. Now the figure over here will make it clear to you. Now this is what is called as an wavelength. Now the electromagnetic wave that is generated, now since it is an energy propagates in the form of a wave motion, now it is called as, it radiates in all the direction, that is the reason why it is called as an electromagnetic radiation. Now let us come to the understanding of the properties of electromagnetic waves. And the first thing is, you have to understand that all the electromagnetic waves that travel at the speed of light. Now the speed of the light is 3 into 10 raised to 8 meters per second in vacuum. Second thing is, these electromagnetic waves, they don't require any material medium for their propagation. Third point is, electromagnetic waves have got electric fields and magnetic fields as their components, which you have seen it in the earlier figure, and they vary periodically with time and space. Sun is a source of almost all kinds of electromagnetic waves. Now these electromagnetic waves are three-dimensional in nature. They are transverse waves, that is because they are transverse waves because the vibrations are perpendicular to the line of propagation. The next point is, these electromagnetic waves have got wide range of frequencies. For example, radio waves, they got wide range of frequencies, or it could be gamma rays, which has got a very less wavelength and high frequencies. And these electromagnetic waves, they react differently with matter. The next thing is, electromagnetic waves like other waves exhibit properties like reflection, refraction, interference and diffraction. Next, vacuum is the only perfect transparent medium for electromagnetic waves, while other media, you can take any other media like water or air, they absorb the energy of electromagnetic waves strongly from some regions of the entire region of electromagnetic radiations. Now this would be more clear when you go on to study about electromagnetic spectrum. The next point, now due to the wide range of frequencies or wavelength, the properties of EM radiations, they differ greatly at different frequencies or wavelength. Now we will be discussing about the electromagnetic spectrum in the next tutorial. Thank you.